Hello everyone. Today we'll be going over how to find the domain and range. So first, let's go over what the domain and range even is. So the domain is all possible inputs for the x values, while range is all possible inputs for the y values. Now, when you're writing domain and range, there's also different kinds of notation, where interval notation is written like this, where uh it's basically just the range. So this would be the domain, and then the range would be written as, for example, 0, infinity, brackets. So you just write them like that beside each other. Um, and for set notation, we will be using for set notation, it's basically written like this, or more like CR. So you'd have to use curly brackets, and this part, XER, this means X is an element of all real numbers. But for this video, we'll be using set notation. So for now, let's practice finding the domain range. So we know the domain is all of the possible x values and the range is all the possible y values. So here we have a table of values, and here we can figure out our domain by making it uh XER and finding all the x values. So we can see there's 1, 2, 3, and 4. So that means our x values are equal to 1, 2, 3, and 4. And then the range is written for all the y values. So here we can see the y values are 5, 7, 9, and 11. So we'd make it y is equal to 5, 7, 9, and 11. Now here we have another case where, so we have this table of values, but we can see that there are repeated numbers. So to get the range of this, you would just write the repeated number once. So it would just be like YER, Y is equal to 4, 7, 9. You don't have to write repeated numbers multiple times. And here with the domain, we can just write all the numbers that are visible down. -2, 0, 1, and 3. So that's how you find the domain and range based on the table of values. Now let's work on finding the domain and range from graphs. So with graphs, first we need to know, first we have to analyze like the starting and end points. So here we can see the starting, they're closed dots. And closed dots basically means uh that those points are included. So here we can see this graph we have where it starts at this point and ends at this point. So basically we know that the smallest is x equals to -2, and the largest is x equals to 4. So the domain would be X is an element of R, -2 is smaller than or equal to X, and X is smaller than or equal to 4. Now we add the equal to because they are closed dots. Now for the range, it's basically it's the same concept. First, Y is an element of all real numbers. And then we can see here that the lowest value is 1 and the highest value is 5. So 1 is smaller than or equal to Y, and Y is smaller than or equal to 5. And that is the same concept. We use plus or smaller than or equal to because they are close dots. Now, moving on, let's try an open dots example. So here we have the exact same graph, but instead the points are open. And when the points are open, that means that that means they're not included. So not included. So for the domain, the lowest x value is -2, and the highest x value is 4. So we'd write -2 is smaller than x, and x is smaller than 4. Now, we don't use smaller than or equal to here because of the open dots. Now, it's the same concept for range. Y is an element of R, and the lowest Y value is 1, while the highest Y value is 5. So we just make it 1 is smaller than Y is smaller than 5. Now, moving on, let's go to an example where we have to find the domain and range of a transformed function. So here we have find the domain and range of f of x is equal to 2f x minus 3, where the parent function is the absolute value function. So for the parent function, we know so this is the graph of the parent function, and we can see that x values just go infinitely, but the y value, it starts at 0 and it does not go less than 0. So through that, we can determine that the domain of the parent function is XER. X is an element of all real numbers, and we can just end it there since X can be anything here. And the range will be Y is an element of R. Y must be bigger than or equal to 0. Okay, so now that we have the parent function, we can get the transformations. So here we can see this this transformation is a vertical stretch by a factor of by a factor of 2. So stretch by a factor of 2, and by BAFO just stands for by a factor of. And we can tell that this here, the 2, is a vertical stretch by a factor of 2. Stretch. Oh, wait. So that's This is a vertical stretch by a factor of 2, and this x minus 3 is a vertical shift by it's a vertical shift by a factor of 3. Vertical shift by 3 units. Okay, so now that we have the transformations, we have to apply these transformations to the domain and range. So the domain is the x values, and a vertical shift by a factor of 3 units affects the x values. But in this function, all we're doing is like moving the graph 3 units to the right, and that doesn't change that still all x values are going to be included in this. So that means the domain is still x is an element of all real numbers. And now for the range. So the vertical stretch, that affects the y value, but all that does is stretch the graph out, which doesn't change where the y value starts because there is no actual shift. So that means our range will also stay the same. Y is an element of R. Y is bigger than or equal to 0. Okay, so that's all for today. Thank you for watching.